Alright, all my Algebra 2 people, welcome to the first part of the Unit 9 notes. We're going to start with 9.1 today. Might have two videos over 9.1. If so, I will let you know, and I will kind of go from there. So, alright. So, again, so this is kind of following the notes. We're doing 9.1, rational expressions, and simplifying. So simplifying rational expressions. Alright, hang on. I'm going to pause this video real quick and kind of fill all this stuff in. Okay, so here are the notes. This says put parentheses. Again, I probably spelled parentheses wrong, but who cares? It might actually be parentheses, kind of like an I there. But put parentheses around any addition or subtraction. Factor if needed / if possible. I probably would say if possible. I would say about 90% of the math work that we're going to be doing for probably these first 3 sections of 9.1, actually maybe even these first 4 sections, is going to be a lot of factoring. And then we're going to cross out any parentheses that are the same, any factors that are the same, and then we're going to simplify numbers outside like a fraction. Alright? So again, alright, so let's take a look at what maybe some of what those kind of steps look like. Okay, so for this first example here, so what I want to do is first off, I'd say the first thing I'm always going to do is, if I do see addition or subtraction, I'll put parentheses around it. But if I look, well, I don't have any addition or subtraction, so I can't really do much with that there. Another thing, I want to see if I also want to see if I can factor. Now, the addition and subtraction problem kind of goes into play there, so the addition and subtraction. It says factor there. So I want to see, is there addition and subtraction? If so, put parentheses. Can I factor? These two questions kind of go hand in hand, because if I don't see addition and subtraction, then I probably am not going to be able to factor anything. All right, I have to have 2 terms in order to factor. So for this first one, 7x over 21. So there's no addition and subtraction, no factoring involved. So now what I'm going to do is just basically treat it like numbers like a fraction and simplify that. So if I take, let's just kind of forget that x for a second. Let's take the number 27 over 21. If I simplify that fraction out, well, I find a number that divides both top and bottom. 7 divided by 7, 21 divided by 7, I get 1 over 3. I add that x to the top. There's no x's on the bottom that I can work with, so my final simplified answer would be x over 3. Alright, go to this one here. It's the same thing. I don't have any addition and subtraction, so I can't really factor anything for number 2. So what I have to do now is I'm going to take these 18 and 12, treat that like a fraction, and let's see, there's a number that divides both of them. That number would be 6. The largest number that divides both of them, 6. I get myself 3 over 2, and then I got x squared over x. If I simplify that, went forward, sorry. If I simplify that out, I'm going to get myself, well, how we simplify that, we just subtract 2 minus 1. I get x on top, so that x is going to go on top with the 3x and the 2. All right. Now, example 3, I got a little bit of something extra going on here. I got an x squared and an x cubed on the top bottom, and then in parentheses I got an x minus 7. Now, in order to cancel out this x minus 7, I have to have basically another carbon copy of this factor down here. I basically would have to have another x minus 7. But since I don't have another x minus 7, I can't do anything with it. I can't simplify this inside the parenthesis with what's down here. I can only do that with what's outside the parentheses. So this x minus 7 is going to stay. And the only thing I can really do now is simplify this x squared over x cubed. And again, if I simplify that, 2 minus 3, that gets me x to the negative 1 on the top of the fraction. But remember, negative exponents move to the bottom, so I'm left with 1 over x, and then I still add that x minus 7 on the top, so I would be left with x minus 7 over x for that one right there, okay? Alright, now for this one here, now I got a little bit more subtraction, so I'm going to start putting some parentheses around these. So as it is right now, with this parenthesis and this parenthesis, they have to be the exact same in order to cancel out. They are not. So now what I do is I'm going to go through and see if I can factor anything. All right. So I put the parentheses around my addition and subtraction. And now for this one right here, so if I'm going to start with this top one, I'm going to see what I can factor out. If I look, well, I can factor out a 4 out. And I take a 4 out, I'm left with x squared minus 25. Oh. And if we look even further, I have a perfect square here. I have an even exponent. I have a subtraction. I can do difference of squares, or what they call DOS. All right. And what I do with difference of squares, I'm going to square root both the terms. And I'm going to write this kind of up here now. So I got 4. I'll give myself a little space here. 4 on the outside, and then in 2 parentheses, square root of x is x. I'm going to put that for the first 2 here. Square root of 25 is 5, so I'm going to put that for the last term for here and here. And then in between, I'm going to do a plus and a minus, or a minus or plus. Doesn't really matter the order there. Now for the bottom one here, I got 4x minus 20. I can take a 4 out of that, and I'm left with x. Negative 20 divided by 4 is just negative 5. So I'm left with 4 and x minus 5. And if I look, hey, look at this. I got a parenthesis of an x minus 5 up top. I have a parenthesis of an x minus 5 on the bottom. Those are going to cancel out. And if I even cancel out my 4s right here, 4 on top, 4 on bottom, I can divide both those by 4 or just cancel them out. Because if you divide them both by 4, that equals 1, and I don't have to write 1 anymore. So all I'm left with is this x plus 5. And there's nothing else that I can cancel it out with, so that would be my final simplified answer there. All right. All right. Moving on to a couple more kind of complex examples here. So I have, for this first example, I got x squared minus 8x plus 12 on the top, and then along with x minus 2 on the bottom. Now for these top ones here, we're going back to our old friends, the trinomials. All right, factoring trinomials. Now remember, it's when we do the little diamond thing, all right, or the little x, cross, whatever you want to call it. What I'm going to do is I'm going to take a times c. What's my c value? A, b, and c. My c value is 12 times 1. 12 times 1 is 12. All right. And then I take my b value and I put it on the bottom. So I get negative 8 on the bottom here. All right. And now what I'm trying to do is I'm trying to find two numbers that multiply to 12 and add to negative 8. All right. Just two numbers that multiply to 12 and add negative 8. And if I look and if I think about it, those two numbers would be negative 6 and negative 2. Negative times a negative gets me positive 12. Negative plus negative 2 gets me negative 8. Now, what I can do with these numbers here, I can automatically, because there's only a 1 out in front of my a there, if I didn't have this 1, I couldn't do this. But because I have this 1 out here, what I can now do is I can write in two factors, here and here. I can write, what's my variable? X. So I'm going to put an x for both of them. And then I have a negative 6, so I'm going to do x minus 6. And then I have a negative 2, so it's going to be x minus 2. And then on the bottom, I got x minus 2. And I'll put that in parentheses as well. And if I look, hey, I got an x minus 2 on top, x minus 2 on bottom. I'm going to cancel those out. I am left with just this x minus 6 on the bottom right here. All right. Example 6. All right, so let's go ahead and see if we can factor. All right. Well, first off, if I take a look at everything, I can take an x out of the top, left with x squared minus x minus 12. Nope, didn't want to go farther there. And on the bottom, I'm left with, take an x out, I'm left with x minus 9. All right, so took the x's out. And now let's see if I can even factor this trinomial out even further. So again, what I'm going to do, and I'm just looking at this trinomial, not this original one, but this one inside. I'm going to do a times c, so negative 12 times the front number, so negative 12. And then b goes on the bottom, so negative 1. And I'm trying to find two numbers that multiply to negative 12, add to negative 1. That numbers are going to be negative 4 and 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. I have a 1 in front of this x squared, so I can go ahead and do kind of what I call the short method. So what I'm going to do, I'm going to put it on top here, x. and then in two parentheses I got two x's for the first numbers, minus 4, plus 3, and on the top I'm going to do x and then x minus 9. So if I take a look at example 6 here, well, I'm going to notice that these x's here don't exactly cancel out. No, these x's do cancel out. But these x minus 4, x plus 3, there's no other x minus 4 or x plus 3 on the bottom here. So this would basically be my final answer there. So I got x minus 4, x plus 3 over x minus 9. If you were to want to multiply that out, we would basically just bring down this. It would be x squared minus x minus 12 on top over x minus 9. Okay. Alrighty, so now for example 7, I'm going to change this one up just a little bit. I'm going to change the top to x squared minus 4. So we're going to have x, and then the bottom stays the same. So x squared plus 3x plus 2. Factor out this top here. Well, I got two terms. If I take a look, I can square root both these. So anytime that I see basically two terms with a subtraction sign in the middle, I would automatically think difference of squares. So what I can do, square root both these. On the top, I'm going to get x minus 2. And then I'm going to get x plus 2. Again, you do x for the first one, plus 2, minus 2 for those, just the square root of 4. X squared plus 3x plus 2, I'm going to do a little diamond thing. I got this times the number out front, so 2 times 1 is 2. Put the 3 down below here. I want numbers that multiply to 2 and add to 3. Well, those numbers are really just going to be 2 and 1. And now, because I have this 1 out front, I can go ahead and set up my two factors. I have an x, so I'm going to put an x for both of them. And then this is a positive 2, so it's going to be plus 2. Positive 1, so it's going to be positive 1. And if I take a look, well, I see that I have x plus 2 and x plus 2 on the top and bottom here. So I'm going to cross those out, and I'm left with x minus 2 over x plus 1. I can't do anything further with that. Can't factor it any further. So that is what I'm left with. All right. Okay. So I'm going to pause the video right here. We'll pick it up with this last example. This will be kind of a two-part video thing for 9.1. Thank you guys for watching, and we'll see you in the next video.